Hello everyone, welcome to Docker Container Certification course. This lab is an introduction to Docker where we will be briefly describing some key terms and concepts that can help beginners better understand what Docker containerization is all about. We assume that you already have some knowledge of command line environment and you know how to manage resources with Chameleon Cloud. If not, there will be a link at the end of the video you can click on to get a quick hands-on tutorial on Chameleon Cloud. This lab is a quick, high-level overview, so we won't be going too deep on each concept, but you can go through Docker's official website to learn more in depth. And by the end of this lab, we hope that you can differentiate between a virtual machine and container and be able to recognize some key terms related to Docker working. This will also be helpful for your following hands-on tutorials. Now, the difference between a virtual machine and container is the layer of abstraction. Virtual machines require a whole guest operating system, and whereas containers don't need installing a complete guest operating system. Instead, they make use of Linux capabilities such as namespaces and cgroups to provide isolation. So why containers is a big deal? The way we build software applications has changed. Before the evolution of containers, we used to build applications as one large piece of code on one huge server with a long development cycle. Specifications, implementation, test, production, etc., etc. And scaling up was also a big challenge. And if we needed to scale up, we needed bigger virtual machines with bigger memory and load balancers, etc., etc. And now we break down applications in smaller parts, not as small as microservices, but small enough to be deployed independently. Containers, the advantages that come with containers is that they are a lightweight form of virtualization since we don't have a complete guest operating system. They're isolated because of namespaces and cgroups, and they have resource limits, so you cannot exhaust the system and there is no memory leak. They're pretty secure. And they have faster deployment because of low overhead, and scaling out is quicker than scaling up in a virtual machine. And decoupled services, that is smaller parts of that large code on virtual machines. Deployment becomes a little complicated because one server, one application to deploy in a virtual machine scenario, but now we have many components on many servers. So all the environments that you want to deploy on, Python, Java, Amazon, etc., and deployment becomes a little complicated, and image portability is a big challenge. So containerization is not something new. It has existed for years, and there is nothing new about containers. But we needed something to address the whole range of two parts of the ecosystem where we have so many ranges of development environments such as Python, Java, etc. And Docker is what addressed the two big challenges with containerization. And since 2013, it has been the most successful container management technology ever since. That's why Docker containers today are like a big deal. Docker is analogous to actual shipping of containers. You put your goods on one end and you tell them where to ship it, and they ship it wherever the destination is. You don't have to know how they do it, and they don't have to know what's in it. So it's on the same way. In Docker containers, you basically containerize your applications and you put it on Docker platform. And using Docker platform, you can now share your images over different environments. So portability is easier and development cycle is less. And if you have many projects, switching is a lot easy. So Docker in itself is like an ecosystem. A couple of years ago, Docker meant Docker Engine, but now it's a whole platform, and it makes building, shipping, and running very easy as compared to other container technologies. So it has been the most fastly growing technology in terms of cloud computing. Some important terms that you have to know is Docker engine. This is what we will be installing on the host. Docker images are basically a collection of files and some metadata. They consist of stacked layers. We will not be going in detail in this video. Docker Hub is like a resource center for Docker, where you can share your work, upload an image, or download an image, basically like a GitHub, but for Docker images. Container is a set of processes, a read-write version of Docker images. If images are classes, then containers are like instances of that class. And they consist of a Docker image, execution environment, and a standard set of instructions. Basically, as just like you would tell the shipping company about where it needs to be shipped and how it needs to be shipped, if it's fragile, etc., etc. So container is like taking care of the application inside. Docker file is what makes portability so easy, because when you write a script, you turn it into a Docker file, and then if Docker file can build on your machine, it can build anywhere. So using Docker files, portability of images becomes very easy. This was a quick introduction. You will now proceed to Lab 2 and Lab 3, where we will be installing Docker engine. But if you are familiar and if you're familiar with installing and want to take advantage of our Chameleon capabilities, then I can tell you to skip Lab 2 and Lab 3 and use our appliances from chameleoncloud.org, which have pre-installed Docker on it. Thank you.